Every image you've ever seen of the solar system is a lie, or at least a dangerous oversimplification. Think about it. From childhood, we've absorbed that familiar picture. The sun shining on one side with planets stretching outward in a neat horizontal line. Mercury, Venus, Earth, Mars, Jupiter, all arranged like pearls on an invisible string. In this mental model, space appears flat. There's a north above our heads and a south below our feet. We've stared at classroom posters and NASA graphics until this 2D map feels like absolute truth. But here's what nobody tells you. Space isn't a map. Space has no floor. The direction we call up stops having any physical meaning the moment a rocket's engines shut off in orbit. Today we're taking a journey most textbooks completely ignore. We're going to travel straight up from Earth, tear apart the flat model we've been taught, pass through the chaotic tangle of satellites just 250 miles overhead, venture beyond the rebellious exiles of the Kuiper Belt, and finally reach a structure so vast it turns our entire solar system into a microscopic speck. Our journey begins surprisingly close to home, just above the atmosphere in what we call low Earth orbit, or LEO. If the solar system truly were flat, we might expect all our satellites to orbit Earth neatly along the equator, forming an elegant thin ring similar to Saturn's famous bands, all traveling in the same direction like cars on a well-organized highway. But the reality is far more chaotic and fascinating. If you could somehow see the orbital paths traced by every object humanity has launched over the past 60 years, Earth wouldn't appear to wear a ring at all. It would look like our planet had become trapped inside an enormous tangled ball of yarn. Here, three-dimensionality isn't just theoretical, it's absolutely essential. Consider weather and reconnaissance satellites. If they orbited only along the equator, they would spend all their time observing the same narrow band around Earth's middle. They would never see Europe, Canada, or Antarctica, so we launch satellites into polar orbits. These remarkable machines travel at 17,400 miles per hour, racing across the sky from North Pole to South Pole at a 90-degree angle to the equator. As Earth rotates beneath them, they sweep the planet's surface vertically, like peeling an orange in strips. Even the International Space Station, the largest structure humans have ever built in space, doesn't travel along the equator. It orbits at a specific inclination of 51.6 degrees, at an altitude of 250 miles. This angle allows the station to pass over most inhabited regions, while permitting Russian rockets launched from northern bases to reach it efficiently. The GPS system alone uses 24 to 32 satellites distributed across 6 different orbital planes, all inclined at 55 degrees. They form a mathematical cage around our planet, ensuring that wherever you stand on Earth, at least 4 satellites are always overhead. At this altitude, gravity still dictates who's in charge, but geometry is already telling us we're not living on a disk. We're wrapped inside a sphere of frenetic 3-dimensional traffic. As we travel farther from Earth, leaving the complexity of artificial satellites behind, a sense of order seems to return. And here we encounter a genuine physical reason why we imagine the solar system is flat. It's not laziness on the part of textbook illustrators, it's the physics of star formation itself. Approximately 4.6 billion years ago, before any planets existed, our future solar system was nothing more than a gigantic shapeless cloud of hydrogen gas and ancient stardust slowly rotating in the cosmic darkness. As gravity began collapsing this cloud to form our sun, something beautiful happened. Conservation of angular momentum took over. Just as a pizza chef spins dough and watches it stretch into a flat disk, our primordial cloud flattened as it spun faster and faster. This created what astronomers call the plane of the ecliptic. When we observe the giant planets of our system, Jupiter, Saturn, Uranus, and Neptune, they appear remarkably obedient to this ancient arrangement. They orbit almost perfectly within this plane, with tiny deviations of merely 1 or 2 degrees. It's this historical coincidence that gives us the comforting but misleading sense that the universe is a perfectly level billiard table, but nature never tolerates perfection for long. Even here in the heart of the solar system, we discover the first signs of rebellion against the flat universe. Consider Mercury, our smallest planet and the closest world to the Sun. Mercury orbits with an inclination of 7 degrees relative to Earth's path. Now, 7 degrees might sound trivial, but on astronomical scales, where distances span millions of miles, 7 degrees represents an enormous vertical displacement. This means Mercury spends much of its year diving far below the Sun's equatorial plane and then leaping high above it. If you could see Mercury's orbit drawn against the sky, you would watch it bobbing up and down like a small boat navigating rough seas, absolutely refusing to stay aligned with its planetary siblings. And here's something remarkable that few people ever learn. The Sun itself doesn't respect our tiny maps. The Sun's equator is tilted by approximately 6 degrees relative to the planet's orbital plane. This curious misalignment suggests something dramatic and violent may have occurred during the early history of our solar system, something powerful enough to knock the Sun itself slightly askew from the disk of material that formed around it. But Mercury and the Sun are merely subtle warnings. As we venture beyond Neptune into the frozen depths, where sunlight becomes just a cold, distant glimmer, the solar system's apparent order begins to completely unravel. Welcome to the Kuiper Belt, a region that demolishes any remaining illusion of cosmic flatness. Most people imagine this distant zone as a thin asteroid belt, similar to Saturn's rings or the debris fields in science fiction films. But the reality is far larger, far emptier, and magnificently three-dimensional. The Kuiper Belt isn't a thin disk at all. It more closely resembles an enormous cosmic donut. The gravitational influence of Neptune has acted like a cosmic mixer over billions of years, gradually scrambling the orbits of countless icy objects and scattering them both above and below the ecliptic plane. Astronomers divide this region into two populations. There's the cold, classical Kuiper Belt, containing objects that orbit relatively politely within the expected plane. But then there's the hot population. Not hot in temperature, because out here temperatures hover near absolute zero at minus 400 degrees Fahrenheit, but hot in terms of orbital dynamics, objects with inclined, eccentric, and wonderfully chaotic paths. Pluto, everyone's favorite demoted planet, belongs firmly to this wild second group. Its orbit tilted by an extraordinary 17 degrees relative to Earth's plane. 17 degrees. Imagine a record player spinning a vinyl disc perfectly flat. Then picture one stubborn object slicing through the air at a dramatic angle instead of following the groove. That's Pluto. During part of its 248-year journey around the Sun, Pluto travels significantly above the ecliptic, and during another part, it plunges far below it. And Pluto isn't alone. There's Eris, a dwarf planet nearly the same size as Pluto, whose orbit is inclined by an extraordinary 44 degrees. Think carefully about that number. 44 degrees means Eris almost completely ignores the concept of an orbital plane. It travels through the highlands and abyssal depths of the solar system, exploring empty regions that no major planet has ever dared to visit. From Eris's perspective, the entire inner solar system looks tilted. It sees the Sun and all the familiar planets not as a line stretching to the horizon, but as a glowing disk shining in the darkness far below, at this point 4 to 5 billion miles from the Sun. The classroom's 2D map has become completely useless. If you're fascinated by the hidden geometry of our universe, consider subscribing and activating the notification bell. Otherwise, YouTube won't show you our next cosmic explorations, and you'll miss what we uncover next. Now, you might be thinking, this is all rather abstract. Distant frozen objects with unusual orbits. Interesting, perhaps, but what does it really tell us about our place in the universe? But here's the thing. We've barely begun to understand the true shape of our cosmic home. Everything we've discussed so far, the tangled satellites, the rebellious planets, even the extraordinary Kuiper Belt, all of this exists within a tiny fraction of the Sun's gravitational territory. The real structure, the one that reveals what truly exists above and below Earth, is so vast and so surprising that it transforms everything you thought you knew about the solar system. So, stay with me as we venture into the deepest void, to a place where the Sun becomes just another star in the darkness. We now travel through a desert that challenges human comprehension, passing the Voyager 1 and 2 probes as we journey outward. These remarkable spacecraft are the most distant objects ever built by human hands, flying continuously for nearly 50 years, currently over 15 billion miles from Earth. And yet on the scale we're about to explore, the Voyagers have barely left our cosmic backyard. We pass the heliopause, that invisible magnetic boundary where the solar wind finally dies and the interstellar medium begins. We enter the deep void, traveling until we reach nearly 1 light-year from the Sun. That's approximately 5.88 trillion miles. At this distance, light from our parent star takes an entire year to arrive. To put this into perspective, after nearly 5 decades of travel, Voyager 1 has only reached 1 light day from Earth. We are now journeying 265 times farther than humanity's most distant explorer has ever traveled. And it is here in absolute solitude, where the sun appears as merely the brightest star in an unfamiliar sky, that we encounter the final structure, the true limit of solar territory, a formation so vast it redefines everything we thought we knew about our cosmic home. Unlike everything we've encountered so far, the Oort Cloud is not a disk. It's not a ring, it's not even a donut. The Oort Cloud is a sphere, a perfect, hollow, gigantic shell that surrounds our entire solar system in every possible direction. Up, down, left, right, forward, backward. The Oort Cloud embraces everything equally. Imagine the inner solar system, the Sun, Earth, Jupiter, even the distant Kuiper Belt, as the tiny yolk at the center of an egg. The Oort Cloud is the shell of that egg, but what an extraordinary shell it is. It begins around 2,000 astronomical units from the Sun and extends outward to perhaps 100,000 astronomical units. That's nearly halfway to our nearest stellar neighbor, Proxima Centauri. In familiar distances, the inner edge sits at approximately 186 billion miles, while the outer edge reaches an almost incomprehensible 9.3 trillion miles from the Sun. Here within this vast shell, trillions of comets drift in the darkness, mountains of ancient ice the size of cities, each one barely held by the weak distant gravity of our Sun. They move so slowly out here, taking millions of years to complete single orbits, suspended in the abyss like frozen memories of our solar system's violent youth. But how do we know it's truly a sphere when no spacecraft has ever traveled there? The answer lies in mathematics and observation. The astronomer Jan Oort noticed something peculiar about long-period comets, those icy wanderers that take thousands or millions of years to cross Earth's sky. Unlike asteroids, which typically arrive from the ecliptic plane, these ancient comets come from everywhere. They fall toward the Sun from the galactic north. They rise from the depths of the south. They arrive from random diagonal angles. The only explanation for this omnidirectional rain of ice is that the reservoir they originate from must surround the solar system completely, like a vast spherical ocean of frozen potential. Scientists believe these objects didn't form at their current locations. In the violent early days, Jupiter and Saturn acted as gravitational slingshots, their immense masses kicking blocks of primordial ice outward in all directions. These cosmic castaways were flung into the void, forming this protective bubble around everything we call home. If you could leave the Milky Way and look at our solar system from the outside, with eyes capable of seeing gravity and ice, you wouldn't see a flat spinning plate. You would see a vast hazy ball, a gravitational bubble drifting through space. All the flatness of the planets, all our obsession with horizontal maps, that happens only in the tiny sheltered core of this immense sphere. We live in the center, obsessed with the plane, while the true structure of our home is a three-dimensional bubble. Faced with this colossal sphere floating in interstellar space, we must confront a question that is both physical and deeply philosophical. What exactly is up and what is down in the universe? Here on Earth, those words seem obvious. Down is where objects fall when released. Down is the direction gravity pulls us. Up is simply the opposite. This institution is a biological tool that evolved in our inner ears to prevent our ancestors from tumbling off cliffs. But in space, the very definition of falling transforms entirely. If you're orbiting Earth, you're technically falling. You're constantly falling toward the planet, but moving sideways so rapidly that you perpetually miss the ground. The sensation of weight vanishes completely. Without pressure on your feet, your vestibular system enters confusion. Many astronauts report experiencing space adaptation syndrome during their first days in orbit. Their brains desperately search for a floor that no longer exists. On the International Space Station, down becomes simply wherever an astronaut's feet happen to be pointing at any given moment. If they rotate 180 degrees, what was ceiling becomes floor. Orientation transforms from physical law into personal choice. Now expand this concept to the galactic scale. We've agreed out of pure historical tradition that Earth's North Pole points toward the up of the solar system. But this is entirely arbitrary. If an alien spacecraft arrived in our solar system from what we call the south, They would observe all our planets rotating clockwise rather than counterclockwise. Their maps would appear upside down compared to ours, and their perspective would be 100% equally valid. There is no cosmic reference declaring one orientation correct. And here comes the final revelation that completely demolishes our flat mental model. Consider the motion of the Sun itself. Our solar system is not stationary. We're orbiting the center of the Milky Way galaxy at a staggering 143 miles per second. But we're not orbiting lying flat within the plane of the galaxy. We're tilted. The plane of our solar system is inclined by approximately 60 degrees relative to the disk of the Milky Way itself. We travel almost sideways, nearly upright compared to the galactic floor. If you could visualize the trail left by the Sun and planets as we move through the galaxy, you wouldn't see flat circular rings at all. You would see a helical structure, a cosmic DNA strand, a magnificent corkscrew drilling through space where the planets continuously orbit the Sun, while the Sun simultaneously drags the entire system forward at tremendous velocity. We're not circling a stationary point, we're spiraling through the Milky Way, writing our existence in loops of motion across hundreds of millions of years. There is no universal north. There is no cosmic grid with arrows pointing upward. There are only masses attracting one another and velocities relative to other moving objects. Everything else, left, right, up, down, forward, backward, these are comfortable narratives we invented to organize terrifying vastness of infinity within our primate brains. Useful stories that help us navigate daily life, but dissolve into meaninglessness when applied to the cosmos. So the next time you step outside on a clear night and gaze upward at the stars, I invite you to try a challenging but wonderfully rewarding mental exercise. Don't look at those distant suns as if they were embedded in a doomed ceiling above your head. Try instead to feel the depth. Remember the sphere. Remember the Oort Cloud wrapping our entire solar system in light years of distance like an invisible shell. Remember that Earth is not a solid fixed floor beneath your feet, but a tilted spinning vessel trapped in a web of three-dimensional orbits that cross and intertwine in patterns of breathtaking complexity. Remember that Pluto is diving into the cosmic abyss right now, that satellites above you are drawing an ever-changing cage around our planet, that the Sun itself is dragging us sideways through the Milky Way at 143 miles per second. You are not beneath anything. You are not standing on top of anything. You are floating, suspended at the center of an infinite volume where the only true direction is outward. In every possible direction, infinity awaits. And that, perhaps, is what it truly means to exist in three dimensions. Not on a flat map, but within a universe that extends without boundary in directions we cannot fully comprehend, yet can learn slowly to appreciate. Speaking of journeys into the cosmic unknown, if you've ever wondered what it would truly take to reach another potentially habitable world, I have a fascinating exploration waiting for you. Check out my video on how long it would take us to travel to Kepler 22b, one of the most promising Earth-like planets we've ever discovered, where we examine the extraordinary distances involved, the technologies we need to develop, and the generations of travelers who might make that remarkable voyage.